Hey, what's going on, guys? KIM-1 here. In this video I'd like to demonstrate my KIM-1 emulator running at 1 MHz clock speed, which is absolutely essential for the authentic KIM-1 user experience, which I'm looking for. And again, like, I didn't yet see a KIM-1 emulator that runs at this authentic speed, which is, well, for me personally, is very important for this project in particular. So last video, we were enjoying the so-called slow motion display updates, and that was happening due to, well, I'm not sure whether I should call it a bug or how exactly to call that, but I can actually tell you why exactly that was happening. And also, well, for me personally, this kind of setting up the custom clock speed, like clock rate, was a bit of a mystery until today, but thankfully to the 652 CPU library that I'm using, and thankfully to the example that is available along with that library, I was able to set up the speed properly. So yeah, now it works like a charm. So here is the deal. First of all, I need to mention one important thing, that the frame rate of this canvas, so the display, the 7 segment LEDs are literally a canvas element, HTML5 canvas element, and it gets updated 60 times per second. And this frame rate is completely independent from the CPU rate, from the clock rate, right? So the point is that, well, actually, bearing in mind the fact that the canvas driven library is a P5JS, which kind of picks up this frame rate like very easily. You just need to say frame rate, and that's pretty much all about it. Otherwise, you would need to create something like this, like an asynchronous set timeout, that then calculate the value for a delay in order to come up with a proper frame rate. But thankfully, P5JS library actually does it for you already, so no need to be bothered about this. So the display gets updated at 6 FPS, 6 frames per second, and this draw function is actually the function that runs 60 times per second. Okay, so that's important to know. And every time what it does, it updates the background, so it like draws the black background, and then it updates every of this 7 segment LEDs sequentially, like one by one. So this is the rendering part. But in order to drive the LEDs, so actually I've separated the routine to drive the LEDs right over in here. So here I have the routine that so two things are involved here. So first is what segment we're writing to, and that is known from a reference in the memory address hexadecimal 1742, okay, which is responsible for that. And the value that we're supposed to be writing to the certain 7 segment LED is available at 1740 hexadecimal. So this is specific to KIM-ROM. So KIM-ROM is setting those values to those memory locations to give the hardware an idea of which one cell to use, which segment to use, and what value we want to display there. Now, if we would be going for absolutely authentic emulation, then it would be like this. So just give you an idea. So actually, assuming the current sort of instruments I'm using, it kind of flickers. It's flickering. It's not really that great, but what we can recall from the previous video. So just to give you an idea, like what is this and how exactly this kind of works. So here we have because before or I don't even know. Well, probably I can go for it already. So you see, like now I'm running up to 1,000 cycles per asynchronous call of the of the CPU loop. So every time we call CPU loop asynchronously, it does 1000 of the CPU cycles. So I hope that's clear. If we, so you just need to remember that here we have the 1000s. So let's set this value to somewhat a measurable like 10. So in this case, you see like it's megahertz are no longer displayed because this is using the math round, so it's like not accurate at this lower rates. So I should be using the hertz there instead of megahertz. But anyway, we have the number of cycles per second. So here we're running around 10,000 cycles per second. And in this case, this is very similar to what we've been looking, what we've been enjoying the previous video, showing this slow motion kind of experience of how the KIM-1 display is actually getting updated. Right, so now we start increasing this, increasing the number of cycles we use every time. So it would be going faster all of the time. So we set this to say 500s, then it's going to be even faster. We set this to 100 to 50. I'm sorry, not 500s to 50. Now at 100s, it's really faster, and you see like the number of cycles is growing. Doesn't print the megahertz because it just gets rounded, as I've been mentioning. So, but anyway, just to give you an idea, and when it just updates fast enough that your eyes kind of get intrigued by this multiplexing effect, then you can see the normal display. However, because of well, I'm not really sure, because of the canvas element is too slow, or maybe because I'm just a dump, I don't know. If I run this at full speed, well, even if I run this, let's say at 500s, and yeah, now it's like not very nice, but it's actually, well, I'm a little bit, yeah, so here it just, it's like because of the rounding, it's not really, yeah, probably I should get rid of this round, or this rounds, to get a bit more precise value for megahertz, because now it's like from 0 to, yeah, it's, and if I go back to 1000s, then, well, here it doesn't go, well, sometimes it does, but, well, anyway, so, and I'm doing this for the very first time in my life, so I'm not yet sure how exactly to measure this properly and how to tune this properly. So this is still this is still in my to-do list for the future. But anyway, just wanted to give you an idea that if this was a real hardware, in hardware it would be like because the LED, when the LED is flashing very fast, and even if it's kind of turned off, then it's not that fast. It can't like turn off that fast. The physical LED can't turn off that fast. So by the time it would be light up next time, it's still kind of being turned on. So yeah, but since we don't have this this feature in this canvas element, then what we do here is, so what KIM-ROM does, KIM-ROM first powers off the LED entirely and then updates with a new value, then powers off and then updates with a new value. So just to give an idea, so for instance, if we set some values, so now we have the value 1C00, the address 1C00, so like 1C00, and here the value of 85, right? But if we go for this sort of a trick here, I mean, so again, it goes twice. I can even show you this. So we just say console.log in the segment, and actually the value plus value. So just to give you an idea, excuse me, can I reference? Yeah, sorry. So I probably can put it here. Okay, so you see, like for every segment, it gives non-zero value and the zero value. So the zero value kind of resets, like turns off the LED, the entire segment, and then next time it calls it, it just enables it with a digit that we need to output there. And if we have a look at the ROM, So at convert digit here, at the convert digit, we see this exact we see this exact thing. So first we turn off the segments, okay, and then we output what we want to output. So this is the first call, whatever segment gets the value of 0. The second call, the segment gets the value of whatever digit we want, like 7-segment code we want to display. So this is in decimal, in hexadecimal, this is gonna be BF, but it's not important here really. All right, and yeah, one last thing. So just since we kind of already learned how it actually works, we can go for a little trick that is just to make it specific, the implementation making specific to the current display library, like assuming the current output, the canvas element, and how it behaves, because it's not the real 7-segment LED. We just can, if the value is equal to 0, we can avoid turning off, and we can just update the values only in case, because just this takes time. So let's get rid of that. And yeah, you already see that it now only when it's 0, it doesn't fire. Only when the value is there, it does fire. Okay, and now the real last thing. So yeah, it's kind of the same effect, but without any flickering. If we now want to set the value, like the address, to say 1C and then to 1C22, this is the entry point when we press the reset on KIM-1. So yeah, we have the address and the value that is specific to that address. That's pretty much all about it. And well, I've been thinking, like, why do we need to turn off the LED before updating it? And well, probably because if we do not do that, then probably it would just it just won't be able to update otherwise. I think that's just the reason. So I think if we just get a new value, then the old segments would still be lighted up, and hence the values would be horribly wrong. So I believe that's the hardware reason behind actually turning it off and turning it on again. But I might be wrong though. So if you guys know how this works, and if this is the case, then fine. If it's not the case, if there is another reason for that, please kind of let me know in the commentaries. So yeah, starting from now, like the next big milestone to consider would be to connect the keypad. Well, probably before connecting the keypad, I would be trying to figure out how the logic of switching between the address entering and the data entering mode is kind of working, and trying to manipulate those, like here from the console. And then definitely I would be going for creating the keypad and actually trying to mimic the user experience of entering the programs and running the programs. And like the keypad is one of the most critical parts because the software, the authentic software like KIM-1 by Bob Leedom, for instance, it relies on the original behavior, on the authentic behavior of the keypad. And if you don't follow that authentic behavior, like for instance on KIM-1 we have a different behavior, so it only triggers the event of pressing the button, but then it times out instantly, almost instantly. So even if you still pressing the button, didn't release the button yet, it kind of ROM thinks that you've just clicked and already released the button. So that's how the ROM thinks. So I have no idea how to do that, but yeah, a couple of days ago I had no idea how to do this as well. It hopefully works. So yeah, it's a very fun thing to learn how this emulation stuff is actually working. So yeah guys, this is from my side. Thanks for watching. Until the next time, and take care.